So thanks all for coming. We're going to talk about the work that we were doing here at Pivotal to get Envoy working for Windows. And just to start off with a brief outline. Nope.
It's Control-Shift and Control.
Why isn't this working? There. Just start with a brief outline of what the talk was going to cover. We're going to start off with an introduction, who we are, who Pivotal is, what is Envoy. We're going to go on, describe the issues that we've encountered, what was solved already, what still needs to be solved, where are we holding, and then we're going to look at our outlook into the future. So just as a brief introduction, my name is Yechiel. I'm an engineer at Pivotal in the Windows containers team. Part of that includes container networking. I've been on the effort to port Envoy to Windows for about a year now. You can find me on social media and on the Envoy Slack at Yechiel K.
And I'm Bill, otherwise known as Rowe, and have been doing porting software for a very, very long time. Was part of making HTTPD run effectively on Windows and make that a first-class operating system. That's kind of what we want to see happen here with the Envoy project, that it's equally effective when it's running under Windows.
Great. So what is Envoy? I'm coming with the assumption that most people here are familiar with it somewhat, but at the most basic level, Envoy is a proxy server. It's used as an abstraction that allows the network to be transparent to the end users, as Matt Klein explained in his talk, in his introduction last year. The goal of Envoy is to be an abstraction that allows higher layer systems to be built that makes the network transparent to the end users. And just a brief timeline of where Envoy came from. Envoy started as an internal project at Lyft back in 2015. Matt Klein started working on a proxy server, which he originally tried calling Lyft proxy, but then Envoy sounded cooler. Then in 2016, the Envoy project became open source. People started contributing. And then in July 2017, when Pivotal started looking for a solution for our container-to-container route integrity problem, we were looking towards Envoy as a solution. And Envoy fit perfectly on our Linux containers. Unfortunately, Envoy did not have any support for Windows, still doesn't. And we started looking around to see if anyone's discussing it, if there's anything. We found there was an issue open at GitHub already. It seemed that Microsoft had started doing some work. And we got in touch with the Envoy community and the Microsoft contributors to see if we can collaborate and help things along. So in the summer of 2017, we had a few meetings between Pivotal, Envoy, and Microsoft to try to hammer out the approaches, divide the work between us, see what was already done. It turned out Microsoft had a fork, a compiled fork based on MSVC, building using MSVC. But the problem was that the Envoy community uses Bazel to build. And in 2018, it was established as a unified build system for the entire Envoy project. And Bazel had issues compiling on Windows. So we started working on the issue a little in parallel with Microsoft. Eventually, Microsoft had to dedicate their resources elsewhere. And in July 2018, we finally had a patched up version of Bazel that was able to work on Windows, and we were able to compile Microsoft's branch on Windows. And we started our work of slowly upstreaming that patch back to the Envoy community. Then the work went in bursts on and off. In March this year, Bill joined the effort and started moving full steam ahead. We've built up a lot of momentum. Recently, Microsoft offered to jump back in and really help us out with some of the thornier issues around load event. And we're really hoping that within a few months, Envoy will be working on Windows. Just to describe what Pivotal's use case, what we needed Envoy for. In short, we need to solve our routing integrity problem for container-to-container networking, where the issue is we're where an app crashes and our scheduler schedules another app on the same container, before our router gets notified, traffic will still go to the old container, even though it's on a different app now. That is not a major problem. It only lasts for a few seconds, but for companies that have higher security requirements, routing integrity is very important, and this is a very big blocker for many of our customers. Envoy would work by getting in as a sidecar into the container and make sure that routing in and out of the container and to other containers remains integral. So what happened already? What have we done already on Envoy? So there are a few problems that were already solved. The main problem, especially around getting others to help us contribute, was to get Bazel working on Windows. And the main problem with getting Bazel working on Windows, one of our biggest bugs was the fact that Windows has much shorter limits on command line inputs than Linux. And passing those long, Bazel passes really long command line arguments with lots of directories, and it was breaking Windows. It wasn't working. Eventually, I mentioned we had a patched up version of Bazel. We got around it, sort of a Band-Aid approach, by first of all moving the entire directory structure into a directory in the root, and shortening that directory's name, and also having some logic to make sure that empty directories were not being included. But that was, of course, only a Band-Aid, and we were already running against that limit earlier this year. But thankfully, Bazel solved that issue earlier this year in version 0.26, I think. They solved it by having arguments passed in not through long command line arguments, but through a params file. And so now we're at a point where pretty much where we can use Bazel, where we can use the latest release of Bazel to build Envoy on Windows, to build anything on Windows. And that is a huge boost, not just in our work. Actually, anyone who wants to contribute now, that'll be a huge help for them as well. Another pleasant surprise was that many Linux-specific socket issues that we've had earlier, earlier this year we discovered that they were actually solved by the work around getting Envoy compiling on OS X. Now Envoy uses BSD sockets, which work on Windows, and that was a huge help for us, not having to do that work ourselves. Problem we've recently solved, Windows headers, which have to be included in many files, especially around sockets and things like that. Windows headers define many common keywords that would break the build, would break anything we tried to build. This code snippet was literally like probably 40 places throughout the code base. Literally any place where we included Windows headers, we had to undef common keywords: true, delete, error, get message, things like that. That was obviously pretty ugly, not maintainable, of course, and really ugly. We solved it by putting all of that into a common platform header file, and now instead of including Windows headers, we just include source Envoy's source include Envoy platform.h. Another problem was that basically a lot of our CMake dependencies were having issues compiling. That was greatly simplified through Bazel 4 and CC, the Bazel 4 and CC library. We got some help on that.
Yeah, this one is interesting because CMake has its own rationale, way of building. Obviously, that is not Bazel. Not only that, almost every consumer of CMake, a lot like your AutoConf, AutoMake projects, the maintainers have their own particular way that they'd like to tweak that build. So basically, in every single CMake-based project out there has its own quirks that make a unified compilation very difficult to realize. So basically, the Bazel community, the foreign CC rules team, runs through the CMake detection process, runs through that whole configuration, and then stops and says, okay, what decisions did CMake make? Let me see a Ninja build file. Okay, now we're going to Bazelify that, and the actual compilation is all handled by Bazel. Our challenge was to strip out all of these rules that all of these other third-party projects had introduced, and that was a challenge.
And finally, the last one that we solved recently was where we had an issue, basically all external dependencies. There was no unified way of doing it. Some were linked in dynamic libraries, some were static. Now we got everything bundled into Envoy static.exe, all the external dependencies. That's a synopsis of stuff we did already. Oh, yeah, I spoke with that. So I'll pass it on to Bill for work that still needs to be done.
And we do have a few other things that we got taken care of. But this is maybe the most important part of our chat here, is that these are problems that are going to be reintroduced by our fellow developers who are living in a OS 10 or a Linux world. And this is just unavoidable. It's a nature of trying to work on any project that's going to be cross-platform. But the issues that can be reintroduced by other contributors, right off the bat, even the way that integers and longs get handled on Windows in 64-bit Windows versus 64-bit Linux, pretty radically different. On Linux, it's all 64 bits. Your int, your long, your pointer, your pointer type are all 8 octets. It's simple. On Windows, this is actually a 64p architecture. So if you're in this room because you're a Windows developer, you already know this, probably. And if you're in here as a Linux architect, you probably know that they're all 64-bit types. So it's a very easy thing to get confused by. Envoy has solved this in a good way internally for their own APIs, and they've basically decided to build everything on an explicit type, whether it's unsigned 32 bits, signed 64 bits, whatever, a Boolean, whatever the type is needed, they try to map it as closely as possible. The problem is, as soon as we start using Bazel or standard C interfaces, we're right back to the same problem of having to speak in terms of ints and longs and how these differ from platform to platform. And we're not the only ones, because now we have the Android and iOS port of that they have been working on at Lyft as part of Envoy. So these are things that we're going to want to work as a community to resolve ongoing. Likewise, MSVC, Microsoft had never, they began Posix implementation. This sounded great. It was part of their federal contracts that they had to implement Posix. And unfortunately, as requirements got removed, that effort stalled. So a lot of things like a file descriptor is not an int on Windows. It would be a handle, it would be a pointer, and that's not even the same number of bytes when it's stored and passed back and forth. So we have the problem of having a half of a Posix implementation. Standard C++ does some great things for us in this respect, but things like the networking stack aren't really well represented by the C++ standard. So we had to work around these things, even things like S-size T. If you're a Linux developer, you know this type, you've used it, and you probably think it's standard C, which it's not, it's standard POSIX. ISO, C++, 25 years later, finally said, we need a signed size or relative distance between two pointers, and they introduced pointer diff. So we've been making a number of changes around that, not only in the Envoy repository, but across a host of third-party libraries and dependencies that the Envoy project consumes. Also, the compiler behaves differently. Microsoft's interpretation of C++ 17 is not identical to the GNU GCC project's interpretation, which is not the same as the LLVM's CLang interpretation of what the spec says. So you can have legitimate differences and incomplete implementations. So as simple as the mnemonic in where your keyboard might not have a tilde character, so you need to have a different way of writing complement. We had ternary operators, which were very short simplified ASCII ways to map those. Well, sooner or later, C++ said that the standard should have the words not, and complement. Microsoft still has not implemented those. So in solving those issues, we have actually, just in the past month, been dwelling on the question of whether we are going to rely on Microsoft Visual C or whether we're going to shift over to using CLang. And it's worth pointing out here that on Linux, on OS X, the implementation of Envoy, the actual binaries you download from them, are built based on CLang. And it's probably familiar to you if you use the Chrome browser or any one of a number of other Google products. So it's very much their favorite, household favorite compiler. And certainly we're going to have the easiest transition with the rest of the community if we agree to share CLang as our interpreter of the language. But we do hope that the project's going to be able to adopt Visual C as well alongside it so that we can see where something peculiar in CLang doesn't really map to other people's interpretations of C++. It will just make the code more portable if this gets caught by the CI very early in a code submission process. And then many of the tests that right now, this is still a work in progress. It'll continue to be reintroduced. Many of the actual tests are invoked by invoking the toolchain, invoking utilities we compile, and with the presumption that we have a bash shell, which is a slightly strange thing on Windows. Of course, we have services for Unix, but we're not relying on that. The Bazel community has adopted MSys2 as their Unix-like behavior platform. But there are just some simple syntactic differences in invoking the command line between Windows and a true Unix that will continue to trip us up. And so some of these tests they need to be adjusted. And let me think. So specific bugs that we are fixing right now, this is the current work in progress, come down to basically three things. The first thing that remains to be done is that Windows is that Envoy, one of the brilliant aspects of Envoy is that you simply alter the configuration, you push a different certificate file, you push a different configuration, and Envoy reacts immediately to reread the configuration on the fly and have a hot restart on the fly. It's already operating with the new endpoints that you've defined, the new parameters that you've defined. And so file change notifications work differently in the Windows 32 API than they do on Unix. None of the Unix compatibility actually helps us because there are two different file system drivers, layers, even if you're running in services for Unix. So that still needs, we have a draft implementation, partly done by Sam Smith at his work at Pivotal, partly done by Microsoft, and so we need to polish that up for submission. Second issue, the process control primitives. This should be pretty obvious, but we don't have a kill command on Linux. The way that signals travel between processes and threads on Unix bears very little relationship to the Win32 API. So we need an entirely separate implementation of the process control primitives to pick up that the process has been forcibly shut down by the OS, to know whether or not the user is requesting a graceful shutdown, or and simply to persist as a background process. requires some additional code around the service control manager. And on Windows, of course, you expect things to run generally as a service. The third and final issue that we are in the process of resolving, and we have been working our way through them, is the Windows socket and handle objects that, like I hinted at earlier, they're not a file descriptor. They're not a simple int. And the actual primitives in the WinSock API differ radically from the better parts of Linux, and differ in pretty substantial ways even from a BSD socket. So in terms of abstracting this, while I said that the C standard doesn't have a great implementation, some object primitives like IO handle and IO socket handle that have been introduced here in the Envoy project will help us ease that transition to something that can look and feel identical even though we're developing the code or compiling the code to Linux versus Windows. Unfortunately, that's not quite enough because with Windows API, the event loop, the event model is level triggered. Basically, Windows poll is somewhat crufty and very frustrating to use. There are alternatives. There's IO completion ports and other models of writing asynchronous code on Windows. But that actually causes us to have to rip out the core engine and replace it with something with a different set of expectations. So this code, while in the short term is going to look exactly like Linux and behave similarly to Linux, we're going to have to do additional work coming in next year. And this is one of those places where we're hoping for Microsoft's partnership in developing and substituting those small bits, those components of Envoy, which give us the event loop for handling 10,000 parallel requests on 20 parallel threads. So speaking of that, libevent is a open source, very mature open source project for event loop for your state engine as the core of your process. This is what Envoy has used since its inception. We're looking at alternatives like libev and libuv are both projects that were approached from the perspective that they wanted this to run and work on Windows, as well as Linux and BSD and the rest. So we're going to have to evaluate which component we're going to switch to minimize the disruption and to avoid bifurcating the whole community into, their implementation and our implementation. So just to talk a minute about the structure of Envoy. Envoy is built of just a pile of extensions. It's a mountain of different components that is assembled together to achieve all the things that you would get to enjoy in terms of the logging and the filtering and the routing. We express so many different protocols in Envoy. It has an enormous amount of flexibility in terms of what filtering you're performing and how. As you know, that touches at the auth stack, that touches at the protocol stack, and we can make seamless transformations from HTTP1 to QUIC, which will soon be HTTP3. So we're going to be able to manage all of these transitions, and we do that by having individual extensions that can be dropped in and pulled out. So if your use case is rather limited in focus and only has a couple of protocols they need to support, you only have one way that your organization wants to do its logging, you can build yourself a custom Envoy that's significantly smaller that doesn't include all of these different extensions. So they're all pluggable. And during the porting, we've basically gone ahead and set this issue aside in order to focus all of our energy on the core, on the main state engine and the basic protocols. And we basically commented out, left aside a number of these extensions. So what we're hoping to accomplish is to find additional community members who are going to be interested in seeing these different extensions now populated on Windows and fully supported and then optimized, enhanced for that environment as well. But the nice thing is that you can have a fairly basic Envoy much more quickly, and as we get these other features developed, we'll be able to go one step further on that.
Okay, so where do we go from here? And what does the future look like? So Pivotal is very committed to seeing this Windows port through. We're hoping we've built up a lot of momentum in the last few months. The Envoy community has been really helpful. They've been really welcoming to our efforts. Matt and Lisanne and the other maintainers were all very responsive to us. And recently, like we mentioned, Microsoft also expressed interest in helping us out and getting this port through. And like Bill mentioned, Envoy is a very flexible platform, so optimizing and contributing and tweaking it for your own use case, all that remains very approachable. The community is very helpful, and it's so the barrier to contribute is getting lower. If you're wondering how you can get involved, the best place to get involved in the Windows efforts is in Envoy Slack. There's a Envoy-Windows-Dev channel. Bill and I are pretty active there. The Envoy community is pretty active, and Microsoft recently got active as well. If you want to see work currently in progress, you can look at the Envoy project on GitHub, especially look for any issues tagged help wanted, and we're hoping to get a custom tag for Windows up soon, which will help people follow Windows-specific issues. And just watch the building and installation page on the Envoy docs to see when a Windows binary will drop. Additionally, the Envoy users channel will be available for peer support once Windows did arrive, hopefully in the near future.
I think I do have just one, while we're on this slide, just one or two other small observations. Probably the key one is that starting on, I guess, Friday the 6th, the Envoy community has a community call, which is just a generalized status meeting once a month. And so now, starting on the 6th, Fridays, we're going to be also doing a little conference call specific to the Windows porting effort for everybody who's interested in one aspect or another of that development. And what I probably we probably should have highlighted, as we have other interested players that are coming to the Envoy effort, whether it's Windows specific or not, because it's such a flexible architecture, because we can add extensions, it's entirely reasonable for a vendor to come in and say, I'd like cool feature X to be, that's part of my product stack, to become part of the Envoy project. Now, that doesn't mean that the Envoy project's willing to adopt that, but it does mean that they've been very active in terms of providing the endpoints, providing the API. Many people will just refer to Envoy as one big massive API. Adding those API extension points to allow the vendors to come in. So we entirely expect that not only will Microsoft be interested in helping make sure that this fundamentally works well, but they may be bringing in plugins and hooks into a specific version of Envoy built by themselves, or other groups. We build one of our own Envoys for Linux for our containers projects. So we expect that there's going to be some customization out there, but these are just different channels that you can reach out and find out not only how grab some low-hanging fruit of some work that could be contributed, but also looking at the bigger picture, extending Envoy further on. And so that's what the Envoy Dev and Envoy Windows Dev channels are great for.
All right, so thank you all for coming. And if anyone has any questions, we'll...
Go ahead. Sure. Yeah, let me, here. Thank you.
So there is something rough timeline or something, anything plan?
So the effort that we've been conducting, as Yechiel mentions, we started in earnest in March, April, and so at this point, we have about 3 more code patches to commit to get it fundamentally working. So we're probably looking at the end of this year. Then going into next year, we have all of these optimizations that, as I mentioned. So when will it be ready for production use? That really is the magic question, and that's going to depend largely on these factors like Microsoft's participation, et cetera, and other community involvement, as well as our own testing and instrumentation. Yeah, so early next year, that's when we're expecting to see some real results in this. And as Yechiel introduced in our use case, I mean, this is a current concern of ours at Pivotal of being able to take and drop this in as a sidecar for our Cloud Foundry deployments. Other questions? All right, well, thank you all very much.